Alright, hi everybody. Uh, just want to keep it going from what we did yesterday. And just to recap, we tackled this bad boy here. We worked our way around the unit circle, we filled in all the degree measurements, and we filled in all the ratios going around them. I mentioned how powerful this thing is. For example, if I were to ask just the straight up question here, what the let's get here. If I asked you guys what the sine of 225 degrees is, we can use this unit circle here, point ourselves towards 225, and reminder, x was always cosine and y was always sine, so we now know that the sine of 225 degrees is negative square root 2 over 2. That's how we use this thing. So, if we were looking at these problems here, and we wanted to figure out what the cosine of negative 180 is, first thing I would do is picture the unit circle and let's rotate ourselves around negative 180, which would put us right there at negative 10. Reminder, when we're looking at cosine, let's write this out here. Remember, when we're looking at ordered pairs like this, cosine of theta is always the x and the sine of theta is always y. So since we're asking what the cosine of 180 is, we're looking at the x value right there. So cosine of 80 is negative 1/2. Suppose we're looking at this one. Secant of 90 degrees. 90 degrees, here we are. Secant, we got to remember what the reciprocal secant represents, and that's the reciprocal of cosine. So if we're looking at cosine here, well, reciprocal of cosine, which means we're referring to the x coordinate here, secant of 90 degrees is equivalent to 1 over the cosine of 90 degrees, which would turn out to be 1 over nothing. Wait a minute, we can't divide by 0, it's undefined. So this is our response. The secant of 90 degrees is undefined. Let's do this with a few more, using the unit circle. Sine of 120. According to the unit circle there, we are going to have a value at square root 3 over 2. We're in the second quadrant, and when we're in the second quadrant, we're looking at the y coordinate there at 120 degrees. I mentioned this yesterday, and that was we have to picture these trig functions as kind of kung fu movies with subtitles here. When it says the sine of 120, what it's really asking here in subtitles is what is the y coordinate at 120 degrees. Sine's always referring to the y value here, so we rotate to 120 degrees, we find the y value right there at 120. Just like if we were to look at this one here, the cosine of negative 315, well, we first have to rotate negative 315 degrees. There's negative 270, negative 315 would be right there at a reference angle of 45, and now it's asking for cosine, which means they're asking for the x value right there. So we have the square root 2 over 2. So we're going to want to have that unit circle out and at the ready when we're dealing with these problems here. Sine of negative 120, rotating negative 120 puts us right there at the 240 mark. So sine is code for the y, so we have a negative square root 3 over 2. Now 510, what you're going to want to do with that first is subtract 360. So when you subtract 360, 0 and 5, we're at 150 degrees. So 510 is coterminal with 150. So we want the x coordinate at the 150 mark, so we have negative square root 3 over 2. Looking at the secant of 90 degrees, I think we just did one like that. Secant of 90, reminder, that's 1 over the cosine of 90. So now that we have it turned into a sine or a cosine, now we can figure out what that cosine of 90 is, which would be 0. So that'll give us 1 over 0. Whoa, whoa, whoa. Can't divide by 0. So therefore, this trig ratio is undefined. Looking now at the cosecant of 330, that's 1 over the sine of 330. So rotating to 330, we want the y coordinate there. We have negative 1/2. So here's two routes you can take here. One route you could take is really the nerdy math way of doing it, saying, well, you keep it 1 right there, and then you got to put that negative 1/2 right in there, and then dividing by a negative 1/2 is the same as multiplying by the reciprocal of that, which would be -2, which would give us -2. Or if you're really thinking on your feet here, reminder, cosecant and sine are reciprocals of each other. So if you're looking closely there and you see that the sine at any given angle is a certain value, in this case -1/2, all we have to do is just flip it over and we have -2. So how do we deal with tangent when it comes to using the unit circle? Well, remember I had you guys write this out yesterday. You guys were telling me that the tangent of, I'll just write it over here, the tangent of any angle was equal to, I'll write it here, tangent of, say, theta was equal to, the most important thing you had here on your note sheet was that it was this, right? The sine of theta over the cosine of theta. And so that's the trick right there. No matter what angle we have here, we can take the sine of that angle and divide it by the cosine of that angle, and we have tangent. So when we see the tangent of 180, we want the sine of 180 degrees, and we're going to divide it by the cosine of 180 degrees. So looking at 180 degrees, the sine of 180 degrees, the y-coordinate at 180 is 0. The cosine of 180, there, the x-coordinate would be -1. 0 divided by -1 is 0. So the cosine, the tangent of 180 is going to be equal to 0. Now if we're looking over here, the cotangent of 60, well, that's 1 over the tangent of 60. Or, I got another way of looking at it. If tangent is equivalent to sine over cosine, what do you suppose the reciprocal cotangent is going to be equal to? That's right. This is the equivalent of doing cosine of theta over sine of theta. You see how I just flipped over sine over cosine to make cosine over sine? So we're going to do that. Let's take the cosine of 60 and divide it by the sine of 60. What was the cosine of 60? The x-coordinate there is 1/2. And then the sine is square root 3 over 2. Yuck, yuck, and more yuck. What do we do here? Well, we have one fraction bar right there. That's the big one. So we're taking these two and we're dividing them. Well, let's just write this a little bit differently. Let's write it out horizontally. We're really looking at this, right? 1/2 divided by the square root 3 over 2. Got a better idea. How about we multiply by the reciprocal? So now if we multiply by the reciprocal of the square root 3 over 2, now we have 2 over square root 3, which notice that those 2's are going to cross cancel, leaving us with 1 over the square root of 3. I think you guys know what's going to happen next. Now we have to rationalize the denominator. So that will give us the square root 3 over 3. So there's our cotangent of 60 degrees. Let's see if we can streamline this work anyway, because we're not going to always be dealing with these values in terms of positive and negatives. We're going to have to really be on our toes here. So what I'd like you guys to do is, if you look at your note sheet here, take a look. What we're filling in here is looking at the quadrant and figuring out if sine or cosecant or cosine or secant or tangent or cotangent will be positive. Those things are lumped together because even if you take a number and you flip over a positive fraction, it's still a positive fraction. Same is true with a negative. So what I'd like you to do, if you haven't done so already, let's fill in the rest of these. For example, when you look at the first quadrant here, sine and cosecant will be positive because remember you're dealing with x values and y values here, right? X is positive in the first quadrant, so that makes sense that cosine as well as secant are going to be positive. Tangent, remember tangent was y over x, and cotangent being x over y. But if everything's positive in the first quadrant, that will be positive. So what about those ones there? Go ahead and fill those in. Notice that if we just focus on sine, and I'll draw a little circle here. Just focus on sine and we're plotting x and y's. And remember, sine's all about the y. Notice that when we're in the first and the second quadrant, because we have to travel up to get to any point here on the unit circle, it makes sense that in the second quadrant sine will be positive, but as we travel down here into the the third and the fourth quadrant, notice now we will be negative. Make sense? Let's do the same thing for cosine, keeping in mind that cosine is all about x. Do you see that with cosine, first and fourth quadrant, because we're measuring x here, first and fourth quadrant will be positive, and then when we travel over here, we're going to be negative. Now, since tangent is sine over cosine, something different happens. Because now, if we're dealing with tangent or cotangent, if we're here and sine's positive and cosine's positive, a positive divided by a positive will create a positive. Here, because we have a negative cosine and a positive sine, when we divide these two, whether it's tangent or cotangent, we're going to end up with a negative result. Down here, because both are negative, we're plotting points. See, notice a negative divided by a negative is going to create a positive for tangent. And then when we're over here, we're still going to have just flopped around there, but we'll still have that negative result right there. So we can summarize it just like this. Positives, all of them are positive in the first quadrant, all six of them. But when we get in the first quadrant, only sine is positive. And then when we get into the third quadrant, only tangent's positive. And the fourth quadrant, only cosine's positive. So if we were to take a circle, we could kind of spell it out like this. Now there's an easy way that we use to remember this in the trig biz, a mnemonic device. And that mnemonic device is called this: all students take calculus. That's a nice little trick you can do to remember which trig functions are positive in their proper quadrants. So we see this, that means all six. Here only sine, here only tangent, and here only cosine would be positive. Let's put it to work here. Take a look at this problem. Let's use the unit circle to find the values of the six trig functions for a 135-degree angle. First, let's plot that angle. 135 looks like that, right? Let's get the x and y coordinates right there using our unit circle. So according to this, we have negative square root 2 over 2 and square root 2 over 2 for the y coordinate. Now, since all students take calculus and we are in the second quadrant, when we're trying to find all six trig functions, the only ones that are going to be positive are going to be sine and its reciprocal cosecant. So when you're trying to figure out all six of these, we can use all students take calculus, the fact that sine is the only one that's going to be positive, and assume the rest are going to be negative. Now, we just fill in the proper values here. If we go here, sine and cosine are staring us right in the face there. Now, what about tangent? Remember, tangent is sine over cosine, or y divided by x. So look at this. We take the square root 2 over 2, divided by a negative square root 2 over 2. I think that's just going to make negative 1. It's going to be some really squirrely arithmetic in there, but remember, it doesn't matter what you take here. As long as it's the same number divided by the same number, you're going to get 1. But now we have the same number divided by its opposite number, we're going to get negative 1. Now what do you suppose we're going to do here for cosecant, secant, and cotangent? Yeah, we're just going to take these three things here and just flip them over. Understand that if you got to cosecant and secant, when you flip it over, you're going to have to rationalize it. Notice that when you flip over tangent, nothing really exciting happens. You end up here, which still simplifies to be negative 1. Here's another place where we use all students take calculus. Or situations where we're looking at any point now placed on a coordinate plane and we just consider its angle. For example, find the values of the six trig functions for angle theta in standard position if there's a point with the coordinates 5, negative 12, and it's on its terminal side. So if 5, negative 12 is on its terminal side, there's our angle here. Disclaimer here, we are not dealing with the unit circle. But it doesn't really matter if we're dealing with the unit circle or not. We're really playing this angle that wraps all the way around here. And if that angle wraps all the way around and we're trying to find the six trig functions for this point here, we're still considering that right triangle that got made with the x-axis, mind you. Remember we talked about that yesterday. Don't ever make it with the y-axis. And so if we were doing that, the first thing that we have in front of us here is we got to figure out what that length r is right there. Folks, what you're going to notice here is that we did this back in 5.2. It's just now looking through it with a different lens. Notice the first thing we're going to do is do the Pythagorean theorem. Nice thing about this one is it works out to a nice clean number like 13. So we'll put that 13 in there. Now our little twist that we're going to do that we didn't do in 5.2 is all students take calculus. Now what quadrant are we in here? Fourth quadrant. So the only thing that's going to be positive here is cosine. Everything else will be negative. And now that we have a 5, a negative 12, and a 13, it's just SOHCAHTOA work, man. So taking care of SOHCAHTOA. Oh, by the way, the angle. Where's the angle, Mr. Cook? I get that question a lot. Since we're still dealing with unit circle stuff on stuff that really isn't a unit circle, remember where the angle we made in all of our unit circles? It was right there with the x-axis. So there's theta right there. So when we're looking at sine of theta here, we did opposite over hypotenuse there. So negative 12 over 13. Or you can write it just like that with that negative floating on the side there. That's okay. And then we just flip them over when it's time to do the reciprocals.